Hey folks, welcome to the NZQA Level 3 Stats Probability paper from 2023. Now the way this video works is that I go through each question and let you know what you need to do for achieved merit and excellence. The best way to watch this video is to pause the video at the start of each question, try the question out by yourself, and then unpause the video just to see how I go about answering these questions. So without further ado, let's get started. Alright folks, so with question 1, what we've got looks like a 2-3-way table. So one of the things I like to do with these tables is just have the totals along the side. So for example, I've got 13 and 43, that's going to be 56, 11 and 38, which is 49, 22 and 32, which is 52. And then what I do is just make sure I do it along the sides as well. So you got 13, 11, 22, that is 24, 46. And then the last one, doing the calculator. Got 43 plus 38 plus 30. That's going to give me 111 for do not like coffee. So once I do that, then I actually start doing the questions. So from the survey, calculate the probability of a randomly selected student being in year 9 or 11 if they stated they do not like coffee. So because it says if they do not like coffee, now that's actually 111, that's the total of people that do not like coffee. And then from there, they've got to be in year 9 or year 11. So we're going to actually have to add up those two values there. So we're going to have probability of year 9 or year 11 given, I forgot to write my given sign, given that not like coffee, do not like coffee. So yeah, we can just write that. So that's 43 plus 38, which equals to 81. So it is going to be 81 out of 111. And we're going to put that as a decimal place. So we've got 81 divided by 111. It's going to give me 0.730. This question is actually worth just an achieved, and we get started. All right, let's go to the next question. So with this question, we've got 4 year 11 stand students are chosen randomly, and then calculate the probability that at least one of these 4 students stated they like coffee. So if you think about it like this, right? And I think you've got to think about it in probability branches. So basically you've got 4 students, right? So we can potentially have they like or they don't like, and then you kind of just keep going, like and don't like and don't like. And if you were to keep going like this for every, so this is your first student, your second student, and then you're going to get your third student and then fourth student. What's going to happen is, now if you look at the top branch, all right, now if I was to keep kind of going like this, at the end, I'm going to have L, L, L. So that's like they all like the coffee. And then I would have like 3 L's and doesn't like coffee. And literally, I just keep going all the way. But there is only one branch. Now, there's one branch which is at the bottom. There's only one branch that'll be where the 4 kids do not like coffee. So if you want to find at least one of these 4 kids like coffee, then all of these rest of these branches that we have, there is going to be at least one kid that likes a coffee. All right, the only branch where nobody likes coffee is the very last one that we're looking at. So what we could actually do is we could actually find out the probability of nobody liking coffee from that 4. And then if you do 1 minus that, you're going to get the rest of those yellow parts actually combined. All right. So that's the yellow parts is where at least you've got one kid that likes coffee. So what we're going to do is we're going to find out the probability of no one likes coffee. No one likes coffee from that 4. So we need to go and have a look at how many year 11 students there are first, and then how many of them don't like coffee. So if we go back to the table right here, we've got, so this is the part we're looking at. We've got year 11 and then 38 of them do not like coffee out of the 49 in total. So we're going to go back here. So 38 out of 49. Now this is the first kind of student if you think about it. So this is 38 out of 49. Now if you look at the second branch, if the first kid is doesn't like the coffee, then we've got 48 kids left, and there's 37 kids that don't like it. And if we were to keep going, we're going to get 36 out of 47, 35 out of 46. So that's the branch that we're looking at where none of the kids like coffee. So we've got 38 out of 49 multiplied by 37 out of 48 multiplied by 36 out of 47 multiplied by 35 out of 46. And we are going to do this in the calculator. So 38 out of 49. Oh no, I did it wrong. Hang on, where are we at? Calculator. Here we go. 38 out of 49. Might do it this way actually. Actually, what I might do is I might just do 38 times 37 times 36 times 35. Then in the bottom, I'm going to do 49 times 48 times 47 times 46. So when I do this, I actually get 0.34. I'm going to go with 3 decimal places. 0.348. So the probability then of at least one of these kids liking it is going to be 1 out of 4 likes coffee is 1 minus 0.348. So if I do 1 minus answer, I'm going to go with 652 actually, 0.652. And that's pretty much it for this question, folks. So it's just understanding that you got to find the probability of none of the kids liking the coffee and then go 1 minus that. So grades wise, correct conditional probability for all 4 students gets you a merit. So the correct probability there is going to get you a merit. Partially correct strategy, 1 minus complementary, working out without. Okay, so I guess if you're looking at the top line there, you probably could get an achieved before you do the 1 minus part. So that's pretty much it for this question. Let's have a look at question 3. So folks, for question 3, what's an assumption you made when calculated answer to part 2? I think the first assumption that we could say that the students' views are actually independent, because I mean we know how students are, right? They follow. So we can say students' views are independent. So that is the first one. So what we're trying to say here is that one person's choice is not going to affect another person. So and I know that in school sometimes we tend to follow our friends. We're like, oh, they don't like it. I do like it, but I'm going to say I don't like it just because they said it. So that's an assumption that we're actually making here, that all the students' views are actually their own. The other thing that we can kind of say that this might not be actually valid because it is a small sample that we're working here. May not be valid as given a small sample. Also, we could also say that because of the small sample, there's a very high chance that the respondents may actually know each other as well. Yeah, so I'm not gonna lie, these assumptions part, I genuinely kind of find it challenging. I don't mind the probability trees and the probability itself, but I always just have challenges with these assumptions. I guess ultimately you've got to look at the context of the question, and whichever way you decide to go with the validity, just as long as you explain it, then you should be okay with that. So as you can see, this is pretty much from the schedule itself. So basically, I guess the correct assumption identified in context, I'm guessing somewhere around here, we're looking at a merit. And then for the last part there, we are looking at an excellence. So it's doing the assumption in context and then discussing it as well, whether it's valid or not. That's what's going to get you an excellence for this question. So I kind of left it halfway through there, but yeah, so I might not get an excellence for it, but definitely will get a merit for this part here. But just keep that in mind. Just with any kind of explanations, is that context and discussion. And if you have something like, is it valid or not, just make sure you kind of explain that. Okay, so let's go to the next part of this question. Next part of the question. It is believed that coffee is more popular as students age. Is this belief correct? Use statistical reasoning. So the first thing we're going to be doing is we're going to be looking at the probability that they like coffee given that they're year 9. So we're going to work out 3 probabilities. So probability that they like coffee given that they're year 9. Then we're going to look at probability of they like coffee given that they're year 10. And then probability that they like coffee given that, sorry, not 10, 11. And given that they're year 13. So I got to go back to the original table. So have a look at like what's the probability that they like coffee given that they're year 9. So if we look at it, we should get like coffee is 13 out of the 56 year 9s. And then we've got 11 out of 49 and then 22 out of 52. So 13 out of 56. Sorry, I'm just going to try and, this is not going to work. So I've got 13 out of 56. And then for year 11s, I have 11 out of 49. And then for year 13s, I have 22 out of 52 that like coffee. So the next step is converting all of these into decimals so that I can actually work it out. So I've got 13 out of 56, which equals to 0.232, and 11 out of 49, which equals to 0.224, and then I've got 22 out of 52, which is going to give me 0.423. So for achieved, it's calculating at least 2 of these probabilities. So you could get an achieved for calculating 2 of these probabilities. That would allow a valid comparison to be made. So I guess with this one, you can kind of answer it either way, because you could actually say yes, because when you compare year 9 and 11 students' probability with the year 13 one, the year 13 one is a lot higher compared to the year 9 one. So if you say yes, then you are basically comparing 9 and 11s versus 13. So you'd write a statement like, the probability for year 13 is much higher compared to the year 9 and 11. You might actually say no if you were looking at 9 to 11 probability drops. So you might actually write a statement that says, well, if I compare year 9 and year 11s, then the year 11s, the probability that they like coffee reduces. So it depends on which group you compare and which one you decide to actually answer. And so that correct conclusion at the end is what's going to get you a merit. Okay, the next one. So part 5, explain. Okay. So I guess the first thing is that the results, so you basically need to take results from both schools, from each school. Combined surveys, because it's a combined survey, right? So we've got to take results from each school and we need to separate it out. So it needs to be separated out, results from each, and also for each group as well. So we've got to separate each school and the group across both islands. Now, once we do that, then we can actually check the results. So for example, the results of like the probability that they like coffee given the year group, they would need to be the same. And ideally, like, we want the sample size to be kind enough similar as well. So yeah, just kind of mentioning those things. So part 5, so what is it? We got partially correct explanation, show some identifiers, independence and context. That's going to be merit. So merit is roughly the top line. Full and correct explanation is excellence. Now, again, I will chuck on the schedule here. So this is pretty much what they have there. Like I said before, it's your understanding and it's how well you explain it. So yeah, let's move on to the next question. All right, folks. So for this question here, what we've got is probability of the next 2 successive quarters shows a price increase. Now, what we're going to do is there's actually 41 quarters that's here, because we can see that from what's listed there. And also what you can do is you can actually count all of these lines here, and you should end up with 41. Now, if you look at how many of them are actually in the positive, so we've actually got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So that's going to be 18 out of 41. So if we do 18 out of 41, we get a probability of hang on, 18 over 41. That's going to give us a probability of 0.439. Now this is for this is the, what do you call it, the coffee will increase in price. That's the probability, right? So the probability of increase is 18 out of 41. So if we're looking for 2 successive quarters, so for 2 successive quarters, so imagine it like the probability tree. So you're looking at increase. So that means we're actually doing 18 out of 41 multiplied by 18 out of 41, because that's like increase, right? So what we're going to do is we're going to square the answer here, and we actually get 0.1927. Now the claim is that he actually said that it's going to be just under 20%. So I guess, you know, we've kind of just shown how this model has been developed. So this is one of those weird triple, you know, 2 questions where you might get an excellence for like a couple of things. So it's going to follow on for the next part of this, follow on with the next part of this question. So the next part of the question says, state an assumption that was made when developing this model and discuss whether or not this is likely to be valid. Sorry, I'm just going to kind of work through here. Now, the first thing we always kind of mention is each price fluctuation. So this is part 2 here. So each of the price fluctuation is dependent, but the problem is that, you know, given the recent price changes and also inflation rates, this is actually not valid. So we can say independent for it to be valid. For each fluctuation is independent for this to be valid. However, with recent price rises and inflation rates, this is not valid, because, you know, it is kind of dependent. And also, if you look at one other thing here, all of these bars are actually kind of clumped together. So if the price drops, there's like, because you can kind of see the clumps here, right? So look at this. You've got a big, always the price has dropped, but then here the price is almost risen, and then you got another clump. Like, it's quite clumpy. So it's, again, this is kind of saying that because of that, it's actually not independent, because they are dependent on each other. So you might actually say like large, I wouldn't call it clusters. I think I looked at the answer schedule before and they said it's all clumped together. So large price changes are clumped or grouped together to be independent of each other. So not valid. Yeah, I'm not sure I'm explaining it. I justify the explanation here, but that's the kind of idea here. So now this question is, like I said, it's a kind of like both of these parts equal one question. So if you do must have denominator of 41, so you could get an achieved for that value of 0.193 and explanation about validity of assumed independence. So you're looking at merit for this, and then I guess the last part is excellence here, looking at the clumpy nature of visualization. Yeah, or talking about the economy. So that's where you get that excellence from. Right, folks, that's question 1. All right, people. So for question 2, looking at this, I can tell that it's a lovely Venn diagram. So I'm going to get started straight up, and I'm going to have 3 kind of circles here. Terrible circles, but you get the idea. What do we got? Coffee preferred, 2 mocha, flat white, and cappuccino. So cappuccino, flat white, and mocha. All right, so we've got 510 people in total. So that means the box is worth 510. Now it says 423 people preferred at least one of the coffee types surveyed in the survey. So pretty much what that means is that this 3 circles combined together is equal to 423. So the outside area, I can figure it out by going 510 minus 423, which is 87. So this is the 87 is the outside area. Now it says 81 preferred only cappuccino. So that is this part here. So all of these people, they preferred only cappuccino, which is that zone. So that's 81 there. I should have done this. Actually, no, let's leave it like that. 81. So that's that one. 38 preferred only flat white. So that's that part there. 29 preferred flat white and mocha. So now, interestingly enough, is like the 29 preferred flat white and mocha. Right, so that's going to be this part here, because this blue zone here is they liked mocha and flat white. So that's going to be 29. 103 preferred mocha only. So that one's not bad. So that's just by itself. None of the people surveyed indicated they preferred cappuccino and mocha. So now the cappuccino and mocha zone is this one here. So none of them preferred that. So that's going to be 0 and 0. And then we've got one more part left over, which is this one here. And we can figure that out because we've got all the numbers that we need. So we just go 510 minus 87 minus 38 minus 29 minus 103 minus 81. That's going to give me 172. So that means this zone, this zone here is going to be 172 because we've got all the other numbers. Now, this I think is the most challenging part. Like once you get this, then the rest of it becomes easy because we're looking at calculate the proportion of people who indicated they prefer cappuccino. That's 81 plus 172. So probability of cappuccino is equal to 81 plus 172 plus those two zeros as well, divided by totally we've got 510. Now you don't need to put the two zeros in there, you could have just done it straight away. So we're going to get 253 divided by 510. So 253 divided by 510, that is equal to 0.496. Grades wise, this is, oh wow, this is a merit question. Okay, so merit for this and achieved for the diagram. That's crazy that this is a merit question. Okay, that's fine. We go to the next question. So the next question says that this is what the next question is. So we've got a claim. Basically, we've got to look at relative risk here. So who preferred cappuccino selected only cappuccino. Okay, so what we've got is we've got probability of cappuccino only given that they preferred cappuccino, and on the other side we've got probability of mocha only given that they preferred mocha. So if you look at this, cappuccino only is we've got 81 out of the 253 people, because 253 people, that is basically this is 253 people who preferred cappuccino, but from that 253 people we only had 81 that preferred cappuccino by itself. So we're going to go 81 out of 253 and then repeat the same process for mochaccino. So mochaccino, we've got mochaccino only is 103. So mochaccino only is 103. But if you look at the actual people that preferred mochaccino, which is this entire circle, that's 103 plus 29, which equals to 132. So when we calculate these two probabilities, so I'm going to do 81 out of 253 first, which equals to 0.32. Then I got 103 out of 132, which is 0.780. So now it says a claim is made that 50% is more likely that people who preferred cappuccino. Yeah, I think it's so what we're going to do is we're going to put the probabilities over each other. So probability of 0.32 divided by 0.780, and we're getting 0.41. Now the problem with this one is that claim is actually not supported, because it was 50% more likely, then we should be getting a positive value here for the risk, but we're not. Like, remember, if it's like twice as likely, then you'd get like 2. This is 50% more likely. Then we should have got a value of 1.5, but we've got 0.41. So we're going to say that claim is not supported, and so as results don't support this, you can say that. But you can kind of say it's more like it is more than 50% less likely, because it's actually reduced by, like, it's almost close to 60%, who preferred cappuccino only, or who preferred cappuccino, to select only cappuccino compared to those who preferred mocha to select only mocha. Yeah, so what you're kind of really saying here is that, you calculate the probabilities, compare the probabilities, and in this case, it's actually going the other way. Yeah, it is 50%. It's more than 50% less likely. So hopefully that kind of made sense there. Grades wise, this question is one probability collected, correct or consistent, 0.78 over 0.32. Oh, okay, wow. Now, if for any reason you did this one as 0.78 divided by 0.32, you actually only get an achieved only. But if you do this, one of the probabilities calculated, you get an achieved. Both probabilities calculated. And if you had written 41% more likely, gets R only. So that's just to keep in mind. But if you do calculate relative calculation, that ends up with a merit. But if you had written something like it's more likely, 41% more likely, then that's actually incorrect, because it's the other way around. And then finally giving the reason gets you an E grade for this. All right, let's go to this question. I had a look at this question, and I'm not gonna lie, it was just, I felt annoyed by it. But anyway, let's give it a go. Now, I'm not gonna lie, I've done probability for a while, and I haven't done it for the last 10 years. But I've not seen this diagram before. But you know what? There's enough happening in here for me to actually understand. Now it says write down the probability that a person who lives in urban area. So imagine it like almost like a table, but the probabilities have already been calculated. So I guess that's the best way to kind of see this particular diagram. So if you look at the probability that a person who lives in an urban area, so this person lives in an urban area, would prefer to have their coffee at cafe. It's simply that, 0.515, because normally you would have like how many people live in urban and how many people like coffee at a cafe, and then you would go that divided by urban. But in this case, this is already done for you. So in this case, the answer is just going to be 0.515. I mean, you can actually write this probability of coffee given that they're in urban is 0.515. So grades wise, that's a straightforward achieved question there. Let's have a look at part 2. I don't know why I put so much space for that. So with this question, the first thing I'm going to be looking at is that they prefer coffee. Let's just look at like one of these things, right? And then we can kind of compare it. So we're going to go with coffee at the cafe, given that it's urban. I think we already calculated that. That was 0.515 from the previous section. And then we can look at coffee given that they're in rural. And if we go back to that, cafe, that's going to be 0.175. So I should have actually put cafe. So if we look at this, we can straight away see that someone going to have a coffee at the cafe is much more likely compared to a person in rural areas, because you've got the probability it's almost triple, 3 times the chance that they're gonna have coffee at the cafe if they're from the urban areas. So we're gonna write that down first. So can be confident that urban person is more likely to have coffee in cafe compared to rural. And I don't think the probabilities will change much, because we've actually got a large sample and it's got a very small sampling variation, so we should be okay with that. Yeah, so proportions unlikely to change given large sample and small sampling variation. So grades wise, a correct pair of conditional probabilities stated from that is going to get you an achieved, blah blah blah, sampling variation, that's going to get you a merit there. Yeah, I guess you can kind of done it a couple of different ways. I mean, you could have actually looked at other probabilities, but the one that we had a look at was going to cafe given that it's urban and going to cafe given that it's rural. Now, I know I could think of a few other ideas, but I don't think statistically, I don't think it'll make sense. You can always argue that there's not many cafes in rural areas as well. So, but yeah. Anyway, let's go to the next question here. All right, so what we've got here is, with this question, we've got a reverse. So complete the values and put the missing information. Okay, so now this has gone into urban and this has gone into rural. Okay, so it's basically the table that we had, but it's been changed around. All right, folks, now for this question here, I'm not gonna lie, I looked at this question, I was like, what is happening here? I cannot make sense of this. Then I realized all you have to do is just rewrite that original diagram and put the probabilities in. Now, I had a look at the answer schedule. I'm not going to lie. They did it through probabilities, but I'm going to do this a slightly different way. And I don't know if it's going to work or not, but I'd like to give it a go and then we can check if it actually works out. So to do this, what I'm going to do is I'm actually going to bring the original table back here. And I'm going to use the original table to kind of work around this. And I'll show you what I mean by it. It might just be, it might work, it might not work, but let's give it a go and see what happens. So the first thing is this. See, now I know that this whole population is worth 510. So if this whole thing is actually worth 510, now the first thing I'm going to work is how many people in rural and how many people in urban. So with urban, I've got 0.72. So I'm going to go 0.72 times 510. And as you can see, I've kind of did this already. I've got 367, so I'm going to round that down actually to 367. And if I do 0.28 times 510, I get 142.8. I'm going to round that up to 143. Now the next thing to notice is that 0.485 of 367 is coffee at home. So I'm going to go 0.485 times 367, and that's going to give me 178. If that's 178, 367 take away 178, I should get 189 for the top, but let's see. 0.515 times 367. Yeah, so that's giving me 189. Going to repeat the same process for rural, so 0.825 times 143, and that's going to give me 118. And then 143 take away 118 is 25. So basically, if you can imagine it like this, right, the whole table is now inverted. So if you look at cafe is going to be 189, not 189, sorry, 189 plus 25. That's 214. And out of that 214, 25 of them have it at the cafe and rural, and then 189 is going to be there. And then if you look at the other version, you've got 118 plus 178 equals 296. So this is going to be, the total is going to be 296. And then at home, what is it, 25, 118 out of that. Yeah, so this one is going to be 118. And then this one here is going to be 178. Now we need to have the actual probabilities of it. So, sorry, the 296 should go at the top there. Just realized. So once you do that, we can actually start working the probabilities, because then you'd go 214 divided by 510 equals 0.420. And then 296 divided by 510 is 0.58, which is that. Then you're going to do 189 out of 214. That's going to give us 0.883, which is this. And then 25 out of 214, which is 0.117. Then I've got 178 out of 296, 0.601. And then 118 divided by 296, that's 0.399. So this is how I did it. Now, in terms of looking at the answer schedule, and I'll show you guys the screen here. So at least one cell correct, 4 values correct as counts or proportion, all 6 values correct either as counts or proportion gets you an excellence. Now, I have done it, kind of reversed it, and I've done it this way, and I've got the 6 values in there. So theoretically, I should be getting an excellence for this question, because all I did was like I converted it to numbers and then I put the numbers back in the table to kind of work it out. If you look at the schedule, they've done a lot of calculations, which, yeah, I understand why they did those calculations, but I guess I just saw the question slightly differently. And if you look at it, the actual answer schedule has nothing about working. They just looking at this part here. As long as all 6 values correct, either as counts or proportions, then you get an E for that. So, to be honest, it's not a bad question to get an E, and considering that you might get like 7 points for that, that's pretty cool. All right, folks, I think that's pretty much it for question 2. Yes, that is question 2 done. All right, folks, so for question 3, 3 friends meet regularly, they've been analyzing blah, 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 yep. Okay, so we've got a couple of things here. So we've got extra strong, and we have not extra strong. So I'm just going to write it like that. And then we've got fair trade, brand, or not fair trade. And then we've got, what do we have? We have totals. That's it. And then we've got, altogether, we've got 15. That's total. 12 of these were from fair trade brands. So 12 was from there. So 3 is not fair trade. 8 of the brands were extra strong strength, so that's 8 and 7. What else do we have? Of which 5 were from fair trade. So that's going to be 5, that's going to be 3, this is going to be 7, and that's going to be 0. So that's my table right there. Please explain if the following events: coffee, probability is coffee is not a fair traded brand. Coffee is not fair traded brand. And the coffee is not extra strong. Okay. So if you look at this particular probability that we're looking for in the table, this is actually equal to 0. So because this probability is equal to 0, this provides evidence. This provides evidence that these two are mutually exclusive events. Okay, so grades wise, correct table gets you an achieved, explanation gets you a merit. All right, next one, odd one out. Okay, so basically for this question here, for them to not get an odd one out, you probably need to get heads, 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 or tails, tails, and tails. Those are the two options, because every other option you get, you're going to have one odd one out. So in this case, the probability of 3 heads is a half times a half times a half, which equals to 1/8, which is 0.125. And then probability of 3 tails is half times half times half, which is 1/8, which equals to 0.125. So total probability. So probability that no one is odd one out is equal to 0.125 plus 0.125, which equals to 0.25. So grades wise, this is an achieved question. All right, next question. Okay. All right, so with this one, why each friend can expect to pay on the same number of times. So what we're going to do is we're going to look at all the combinations, all right? So we're going to have person A, person B, person C. And if you look at it like in terms of, actually no, what I might do is I might just do a tree diagram. So we're going to get heads or tails, and then person B will get heads or tails, heads or tails. And then person C will get heads, tails, heads, tails, heads, tails, heads, tails. So we're going to have all of these options. So person ABC, so we've got heads, heads, and heads, 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 and tail. Heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails. All right. So those are our 8 options there. Now, if you look at in the previous question, we had these 2 things happening where they had to flip again. So that means they've got to flip again the coins, right? Now, there's a situation where the odd one is C, is when you get heads, heads, tails, or tails, tails, heads. So in this case, person C is the odd one out. For person B, it's going to be heads, tails, heads, or tails, heads, tails. So in this one, person B is the odd one out. And finally, you get heads, tails, tails, or tails, heads, heads. And in this one, we actually have person A as the odd one out. So as you can see here, there are 8 possible outcomes. And out of the 8 possible outcomes, everybody has an even chance. They have the same outcomes. They all have like 2 out of 8 outcomes that's possible. So what we're going to do is we can say each friend can expect to pay the same number of times, as they all have 2 outcomes. Cool. Grades wise, achieved is for the table or something that you do here, and then merit is the write-up. All right, next question. All right, folks. So for this question here, we've got to work through a probability tree. Now I'm going to go back to the previous question, and if you look at it, there is a 1 in 4 chance that they've got to flip again, right? And 3 in 4 chance that one of them is already paying. So if that's the case, then we can actually write up the tree like this. So there's a 3 in 4 chance that they don't flip, or 25% chance that they flip again. But then in the second flip, it's still going to be 3 over 4 and 1 over 4. The third one, 3 over 4 and 1 over 4. The fourth one, 3 over 4, 1 over 4. And then the fifth one is 3 over 4 and 1 over 4. So if you look at it like this, so these are like the first 5 flips, right? So here we have a result. So it's got to be this branch plus this branch plus this one plus this one plus this one. So we've actually got 5 branches that we need to keep in mind that we need to add up. Now there is a quicker way of doing this. So you could actually do 2 ways of doing this. The first method is you could actually go 1 minus a quarter to the power of 5. Because the reason we're doing quarter to the power of 5 is that's their pink branch there. That is the probability that they would have to actually go more than 5. That's one way of doing it. The other way of doing it is actually adding up each of the branches. So 3/4 plus the second branch, which is a quarter times 3/4, plus the third branch, which is going to be a quarter squared times 3 over 4, plus the fourth branch, which is a quarter to the power of 3 times 3 over 4, plus quarter times to the power of 4 times 3 over 4. Now both of these probabilities is actually like they're not equal to each other. Well, actually no, 1 minus that should equal to each other, because I would get 1 to the power of 2024. Yeah. So let's work out this one here. Now, like I said, I mean, I don't want to work out the probability because I know I'm going to make a mistake somewhere. So that's why I'm going to do the reverse. But you know what? Because this is a video, let's actually do this and see if I can actually do this right. It's going to be painful, but you know what? Let's just do it. 3 over 4 plus 3 over 6 quarter. So that's going to be times 3 times 4 plus a quarter squared. Surely there's got to be a quicker way to do this. Yes, there is. So I'm going to do 0.25 just because it's so much easier typing it in with that. But also I'm gonna go, yeah, let's just go 0.75 plus 0.25 times 0.75 plus 0.25 squared times 0.75 plus 0.25 to the power of 3 times 0.75 plus, that's gone up to the top there, 75 plus 0.25 to the power of 4 times 0.75. So I'm actually getting this, and I'm gonna convert that to a fraction, which is equal to 1023 divided by 1024. And then if I was to do 1 minus 0.25 to the power of 5, I get the same value there. So as you can see, both of these things is equal to the same thing, which is 1023 over 1024. So that's the probability. So if we look at it expected time, so if we actually go 100 times the probability, I just realized that actually no, it can't be times this probability. This probability is that they never had to pay. So we've actually got to do 1 minus that. So 1 minus 1023 over 1024 is going to be 1 out of 1024. So there is a 1 in 1024 chance that it'll actually go above 5 times at any meeting. So if I do that, 100 times 1024, 1 over 1024, so 100 divided by 1024, so I'm going to get 0.097 times. So as you can see, that number is really, really low. Basically what that's saying is that after 100 visits, you would expect less than a tenth, I think, less than 1/10. So this is not, it's not an unusual occurrence. Unusual. Cool. So grades wise, if I'm correct, probability is P, 1 flip or 2 flips isn't achieved. So somewhere here you could potentially get an achieved. Correct calculated probability calculated for more than 5 flips. More than 5 flips. Yep, so that's going to be the 1 over 1024. You've got to get, for excellence, you've got to get the 0.097 and then the statement as well, and that should give you an excellence for this question. Okay, next one. All right, folks, so for this question here, it says discuss how carrying a simulation would help friend A decide. It does say you don't actually need to design the full simulation, but just kind of like a rough idea. Now I'm gonna kind of write a couple of notes here, but I think in your exam you probably need to expand it a bit more. So for starters, simulation would actually help see the variation, especially for the number of times each friend had to pay. So it gives you an idea, number of times each friend had to pay. So I probably would do like a sample size of 100, and I'd keep the probabilities equal to 1/3 for each friend. And then once the simulation is completed, friend A could compare their 49 with the simulation to see what's happening actually. Or basically they want to see whether they're going to get 33 or not. And then once that's done, a decision could be made, blah blah blah. A decision could be made whether friend A has been unlucky, or I guess in statistical terms, unusual. Cool. So grades wise, I think it says simulation will allow the friends to see there's a variability, blah blah blah. Yep. So if you mention some sort of variability, you're looking at an achieved. It would allow the friends to see that they need to consider. For excellence, yeah, merit is without parameters. I think that means that you're actually saying that you're not putting the probability as 1/3. I'm assuming, I could be completely wrong. Excellence is clear discussion of how a simulation with why am I reading this? Let's just have a look through this. With parameters stated would allow the friends to see what they need to consider. Some friend has been unlucky. So basically give the parameters for the simulation and then compare the simulation answer with the collected answer of 49. And then that might give you an indication whether this friend has been unlucky or not. Cool. So that's pretty much it for this question here to get an E. Cut scores for this paper, we are looking at 15 for merit. Achieved is 8 to 14, and excellence is 19. That's it's not bad. I mean, like, you get a couple of can get like 2 M6s and 1 E7, and pretty much you're rocking with an excellence. So you only need to get 1 excellence question correct and 2 of the merit questions correct, and I think that should set you up for this. And considering this question is here, which should have been, if you had done it my way, you probably would get an easy excellence. I don't know about this method. But yeah, so that's pretty much it for the paper, folks. Right, folks, that's pretty much it for this paper. So any comments or feedback, drop it in the comment section below. I'm sure I've made a lot of mistakes here, which I'm fairly confident that I have. So if you do have better explanation of those kind of wordy questions, which I'm not a huge fan of, please feel free to elaborate in the comment section. Also want to wish you guys best of luck for your exams, and if you have been actually following this channel for the last 3 years, thank you so much. Yeah, all the best for your future moving forward. Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.